So we've been practicing a lot of subtraction lately, and we have been knowing that it's subtraction. How? How do we know when we see a problem that it's subtraction instead of addition or any other kind of math? How do we know? Kimmy?
Because in addition, if like it's a word problem, we usually say like how many in all.
In all, so we're like combining those or putting them together. What about when it's a subtraction problem? How do we know it's not combining, Nick?
If someone has 500 or random stuff and someone else has 401 random stuff, how many more does the first person have for random stuff than the other person?
So you're comparing those two numbers, like how much does this person have versus how much does this person have. And so we're like separating those two numbers. We're not combining them or putting them together, we're separating. So Dawson, some ways that we have been practicing separating: breaking down place value, lining up our place values, hundreds, tens, and ones, using base 10 blocks, and yesterday and the day before we practiced subtracting across zeros. And after 2 days of work with zero, I think that these mathematicians are feeling pretty comfortable, so I'm happy and ready to move on. One way that we haven't talked about really in depth yet, but I'm seeing lots of people starting to use, is that part, whole picture, which really impressed me because we haven't really talked about it. I haven't asked you to use that strategy yet, Emma, but I still see some people using that part, whole. So I figured it would be a good time to discuss that so that we all can use it and feel comfortable with it. So that's going to be our focus today. I would like for you to read this sentence with me in 3, 2, 1. Mathematicians can draw a picture and write a sentence to solve separation problems. Ooh, that's a lot of words. So the mathematicians, who are they? Us. We're the mathematicians. We can draw a picture. What kind of picture do you think we would draw in math? Do you think we would draw a picture of our family with our dog playing in the yard and our cousin Bobby on the swing set? What kind of picture do you think mathematicians would be drawing? Kaylee?
A part, whole picture.
Okay, there you go. Maybe a part, whole picture. Are there any other pictures that we could draw that a mathematician would normally use? Sadie? Base 10 blocks. That counts as a picture too. Any other types of pictures we could draw? Nick?
Diagram.
A diagram. Kimmy?
Tally marks.
Tally marks. Gracie?
Base 10 blocks.
Base 10 blocks. Yeah, I think we've said that. Emma?
You can use the standard way.
Would that be a picture if we use the standard way? No. So we're not going to do the standard way today. Today we're just focusing on pictures. And the specific picture that I would like to focus on is one of those part, whole pictures. And it also says we're writing a sentence. What sentence could that mean? Like a sentence like, I like the color blue. Would that have anything to do with math? What kind of sentence, Evan, do you think I'm talking about?
Standard way, break down place value.
Okay. So like standard way or breaking down place values, those are written like a sentence. So does my sentence need to start with a capital letter for math and end with a period or some kind of punctuation?
No.
Nick, I see you shaking your head no. What kind of sentence am I talking about?
A number sentence.
Oh, a number sentence. I like that he used those words, number sentence. So what I'm talking about, if you guys would scoot back for me so I can stand in front of the board, that would be so helpful. Thank you. So the kind of problem, the number sentence that Nick was talking about is like some number plus or minus another number equals a final number. So we know we can put letters in here. Let's go with a D for Duggard, plus E for Evan, equals K for Kimmy. It doesn't really matter. These are numbers. And it could be plus, it could be minus, it could be multiplication, it could be division. Sometimes our number sentence might look like this.
Yeah, I know. What?
They could look like this as long as there are the numbers that we are working with and an answer. We need both. Okay, so here's, let's do a problem together and see what we can come up with. There are 2 lunch periods at Central School. Bless you. 2 lunch periods at Central School. 221 people eat lunch during the first period. How many people eat lunch during the second lunch period? So that tells me 2 lunch periods. Those are our 2 parts. And here in this picture it tells us our 2 parts. 221 people eat lunch during the first period. And we have to know how many eat during the second period. So this sign from the school tells us right here that there are 458 students in the whole school, Kaylee. The whole thing. 221 of them just eat in the first period. We have to decide how many eat in that second period. So here's a part-whole picture for us, and we're missing this part here. So can someone help me write a separation sentence? Because we're separating the first period of lunch and the second period of lunch. Can someone help me write that separation sentence? Dawson, what do you think?
221 minus... Well, I think the sign over there says 400.
So there's a total number of 458. And we can see this part-whole picture here. The entire thing is 458. The part that we know is number of students in the first period. The part that we don't know yet, Riley, is the number of students in the second period. Riley, can you sit on the floor with everybody else in our group, please? Will you join our group, please? Thank you. So we need to figure out what the other part is, the second period, how many people are in there. So help me figure out that sentence. Will you turn to someone near you and tell them what you think that sentence would be?
458.
Kinley, hands off, please. Who are you talking to? Scoot up for me, Nick. All the way up here. I really like listening to Kimmy and her conversation, so can I come back in 3, 2, 1, 0? Kimmy, will you share what you and your partner were talking about?
This would be this sentence. 458 minus 221 equals 5.
And where did you get these numbers from? 258 what?
Students.
Equals something we don't know yet. So we have 458 students. And why did you take away 221 of those students?
Because it's one of the parts.
It's one of the parts, and we're separating, right? So we don't know what the answer is yet, but we have some strategies to help us figure out that answer. I need to know what strategy you would use. If this were our problem, 458, take away 221, what would our answer be? How could we figure out an answer? What strategy would you use, Alana?
I would use standard way.
A standard way, okay. That seems pretty popular. It's not my favorite way, but we can try it. So we'll start with 458, 221, and of course we are lining up all of the place values. Ones column, tens column, hundreds column. So if we subtract 8 ones, we take away 1 1 from that. Anyone can tell me how many ones that is? 7. Then I have 5 tens, take away 2 tens. Would not just be 3, it would be 3 what? 3 tens. 4 hundreds, take away 2 hundreds, would be 2 hundreds. So I'm pretty sure my answer is 237. But Kaylee, I need to solve it in a second way, because I have to be sure what my answer is. Riley, will you sit right behind Maddie, please? Thanks. I need a second way. Maddie, can you help me out with a second way? What strategy would you use? Base 10 blocks. So which number am I going to draw? 458 or 221? Which one am I going to draw, Maddie? Okay, so I'm going to start with my larger number, 400. I'm going to change color. 4 hundreds, 5 tens, 8 ones. Okay, so I've got my number. How do I get rid of 221, Blake P? How do I remove that because I'm separating these? How would I separate 221 from this picture?
You will separate 221 from 455 by taking 200s away.
Okay, why did you start with the hundreds place?
Because the hundreds are easier to take away than the ones.
Okay, but what if I have to regroup? What if I don't have enough ones and I've already taken my hundreds away? and I won't have anything to borrow from. Now I've done the problem in a standard way, and I can see here that I haven't had to regroup anything, but I want to be sure. So that's why, Blake, we always start with our smallest place value, which is ones. So if I wanted to take away 1, 1, how would I do that?
You would just X out 1.
Okay, X out 1, 1. What about 2 tens? I need to get rid of those, Evan. Can you walk me through the rest of this problem? 2 tens?
Take away 2 tens. And take away 2 hundreds.
How do I find my final answer? Marissa, can you tell me how to find my final answer?
You can add them all together at with the tens, hundreds, and ones.
Okay, so how many hundreds do I have left?
2,
How many tens?
3,
How many ones? 2, 3, 4, 5, 6, 7. So I am pretty sure that n equals 237. When I did it the standard way and base 10 blocks, when I did them both ways, I got the same answer. So my last step here, since I'm drawing a part, whole picture, I have to be sure 237 and 221. If I add these together, it actually tells me the whole thing, 458. So that's my last step. I'm going to try that here. Let's move this picture up just a smidge. 237 is our goal here. So 221 and 237, is it actually 458? We'll find out. And if we do get 458, then we know we have our right answer. So 1 plus 7 ones is?
8 ones.
2 tens plus 3 tens?
5 ones.
Excuse me, 2 hundreds plus 2 hundreds?
400.
458 and 458, it matches. So I am absolutely positive at this point that 237 is my answer. Today I'm going to give you some time to work on your own, and I would like for you to include a part, whole picture. Is that the only way you should do it?
No.
Definitely not. You can see here we did lots of other work to support our part, whole picture. But I would like to see that on your paper. I would also like to see a number sentence like this one. So I'm going to highlight those 2 parts because that's what I would like for to see. This part, whole picture and a number sentence. Those are 2 things I would like to see on your paper. When I say go, you're going to head back to your seats. Brittany and I are going to pass out your problem-solving page. What do you think you should do with that problem-solving page? Kaylee?
You should get your math notebook and just glue it into your problem solving.
Yep, math notebook glued into your problem-solving section. Who should you ask for help if you need help, if you get stuck? Gavin? Your AB partner. What if you and your AB partner can't figure it out? Kimmy?
You might want to ask that person next.
Yeah, ask someone else. And if you and the people around you really can't figure it out, then you can raise your hand and I can help you out. But I want you to be trying this on your own without me. So when I say go, how are we moving? Maddie? Quick and quiet. Go. Brittany, would you pass these out to table 3 and 4? I love how Alana went back. Thanks so much for your leadership, Alana. Thank you, Chase and Tyler. Very nice job going back. Emma, will you please go wash your hands with soap since you've had your hands in your mouth?
It is all bloody. Yeah.
I love how quickly and quietly Nick went back. Thank you, Nick. Thank you, Sadie. Thank you, Kendall. Nice job, Marissa. we're going to get started right away. Thank you, Gavin. Going to get started right away. Alana, I love how you started right away. That's wonderful. Thank you. Can I see Tyler, Chase, and Dawson? You can sit there, Tyler. Chase, right here. There, just sit down. Okay, this was from our exit ticket yesterday when we were doing some subtraction, and all three of you got the same answer, 68. And so I want to talk about how you got that answer. So our number that we started with was 306, and we are taking away 248, correct? Is that what everyone has on their card? Okay. So in this case, when we were separating these two numbers, we had to regroup, and there was a 0 in here, and that threw you for a loop a little bit. So let's talk about why we would break this down. Let's draw our picture. I noticed all three of you solved in the same two ways. You did the standard way and a picture with base 10 blocks. So let's take a look at base 10 blocks first. So I'm going to draw 3 hundreds, no tens, 6 ones. So in our problem, when we start with our ones, we have to take away 8 ones. But we only have 6 ones to cross out. So where do those other ones come from? Normally they would come from the tens, but like I said up here, we don't have any tens. So we have to go all the way to our hundreds flats over here. So we take this hundreds flat, I'm going to scribble it out because we're breaking it up into 100. Would it make sense for me to draw 100 dots?
No.
That would take way too long. That wouldn't be a good use of my time. So I'm going to go with tens. How many tens should I draw?
10.
Right, because there are 10 tens in 100. Have a seat, please.
Can I draw the 10? Why did you decide the thing is because the blood is coming out everywhere.
Okay, just go to the nurse. You're okay. So, like you said, 10 tens. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
That's what we did.
So that's a great start. So can I take away 8 of my ones now?
No.
No. So this is what we call double regrouping. Because we regroup this 10 into 10 tens. And we have to regroup again to get our ones, because we still don't have enough ones. So what that looks like in our standard way, so far we have taken away 3 tens and given ourselves 2 tens, or I'm sorry, 2 hundreds and 10 tens. That's what this looks like so far. But like you said, we still don't have enough ones. So that means we have to regroup all over again. So we're going to regroup one of our tens. Now that 10 is gone, and we're going to give ourselves 10 ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what that looks like on the standard way is that we're taking away our tens. Now we have 9 tens. And how many ones do we have?
16.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that's what our problem looks like so far. The place where I see a mistake on your standard form ways is that you didn't do this step, this double regrouping. When you took away that 10 to give yourself 16 ones, you didn't change it to 9 tens. You still kept that 10 there. And I think that caused some error in your answer. So now that we have enough 10s, let's take away 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. How many do we have left?
8.
8. So I'm going to put my answer there. Now I'm going to look at my 10s, and I need to take away 4 of them. 1, 2, 3, 4. How many do I have left?
5.
Now I'm going to take my hundreds away. I need to take away 2 hundreds. How many hundreds do I have left?
0.
So what should my answer be?
58.
58. And what is the answer you wrote on your card?
68 apples.
68. So that it threw us off by 10, because this 10, in your picture, you might have scribbled it out, but in your problem, you did not regroup twice. You just regrouped once. Okay, so I'm going to send you back to your seat to keep working on the problems for today, but I want you to pay extra close attention to that double regrouping part. Okay? Thank you. Head back to your seat.
Oh, so if like we have to use 2, and if we have to borrow from here, we have to have a 9. And
Yeah, because we borrowed to make it a 10, but we still didn't have enough. So we had to borrow again or regroup again.
Okay.
Good thinking. Yes, Chase?
Why is the iPad moving on its own?
Because that's just what it does. All you have to worry about is separation problems, though. You don't have to worry about that iPad. Don't worry about it. Thank you, Riley. Time for you to go.
1 minus 1. 1, 2, 3, 0.
I just pulled my small group, so I'm good there. So now I'm just looking for that kind of exemplary work. We've been practicing regrouping across zeros, which has been a feat. So today we are focusing on other ways to express that thinking, because they all just want to go to the standard way.
Right.
So we're doing that like part, whole picture.
Okay.
So
All right.
as they need support, that's our focus, is just getting away from the standard way. Yeah, yeah.
Okay.
I see that you have solved in a way over here with base 10 blocks. I really like that picture. Can you draw that nice and big on this paper for me? And then did you check over here and get the same way, the same answer? Awesome. Wow, 3 ways. You're so lucky. Now you have time for a 4th or a 5th way. What a guy. And I forgot to tell you, with your picture, will you also write the number sentence that goes with your picture? Thank you. I like this way that you showed right here. Can you draw that nice and big on a paper for me? And remember to write your original number sentence that goes with that strategy here that you used, okay?
Oh, you mean like the
Like this number sentence. And I want to see this strategy.
so like 254. I mean, not that. Oh yeah, 254 minus 135.
Equals a letter. And then you're going to show me this strategy that you use, breaking down your place values. Okay? Thank you. So on this one you got 19, and on this one you got 19? Okay. Well, try it in a different way and see if you get a different answer, or if you get the same one again. Ooh, a number line. I'm interested to see how this pans out. Will you raise your hand when you're done with the strategy? Thank you.
I gave her that suggestion.
Oh, what a good partner. Would you mind showing me this strategy that you used to check this part-whole picture? And then write your original number sentence on that poster too for me. Thank you, Gavin. Yes, thank you. Yes, Silas.
So, is that the answer for the, like...
So this is our whole total number of people in the race, 254.
Okay.
The part that we know about is 135.
Okay.
So what is this missing part over here to get to our total 254? So we've got to separate these two numbers, the whole number of people and the part that we know about.
So it would be 135 minus... Wait, no. Would it be plus?
If we're separating,
No.
right, when we separate, normally we would use subtraction. When we combine, that's when we're adding.
Okay, so...
So you can use addition to help you solve this problem. But what we were just working back at the white table was subtraction through separation.
Okay.
Okay? Yes, Brittany.
The next problem.
Yep.
I did it.
Yes.
Can I take my shoe off for my ankle really hurts because it's starting to blow?
Why don't you leave your shoe on, but prop it up in the chair next to you, okay? Yes.
I was checking and I got 255 when that's 254.
Oh, interesting. So there might be an error somewhere. That's why we always solve in two ways, because here you got two different answers. So what's a third strategy that you could use to decide which one is the real answer?
I don't understand place value blocks when it's like this.
Okay, so don't use place value blocks.
I don't understand breaking down place value over here and I don't know when the other way is.
Oh my goodness, so what are you going to do?
Don't know. Put it away.
You wish. Put it away. I would suggest talking with your AB partner. I would suggest thinking of a strategy that makes sense to you. Solve it in a way that you understand. It doesn't have to be my way. It just has to be a way that makes sense to you. Okay? Thank you. Take your marker. Interesting. So did you check this answer? Did you combine these two?
I put that and I put the total. Then I did this. I was subtracting all of it and I got 149.
Okay, so did you combine these two and see if you really get 254?
No.
Well, try it, so that way you can check.
So where are your tens at?
It doesn't count as a picture, but it does count as one of your
Where are your
strategies.
tens at?
Okay, and what about that?
Okay,
Yeah,
so
base 10 blocks are a picture.
Right.
Is that
Number sentence. Yes,
what's a diagram?
a picture.
mean is this is what they mean is just like a
Yes, sir.
Do you want me to write that?
Yes.
Okay.
Oh, thank you, Gavin. Thank you. Yes, ma'am. Like to check for reasonableness?
Yeah.
I think that would be fine. A fine way to check your answer. So tell me about the pictures that you use to help you solve. So that is definitely a strategy, but using place values doesn't count as drawing a picture because you're writing these numbers in standard form. It's not the standard way, but it's still writing those numbers in standard form. So I do see a base 10 blocks picture here. What about in this problem? I see base 10 blocks. Why don't you think of another picture you could draw? Challenge yourself a little. What do you mean you can't do it? You did like 5 ways on both of those. You can totally do another type of picture.
I tried a different way with 120 minus.
Have you talked to each other yet?
Yeah.
Oh, do not lie to me. Talk to each other first and then I can help. Have you talked to Tyler and Gavin yet? Oh, then you're not ready for me. Hey, thank you. Would you please meet me in the book nook with your notebook, quick and quiet? Marissa, I loved how you came over. Thank you so much. Sadie, great job coming over quick and quiet. Thank you for your leadership, Nick. All right, so I saw a lot of great work as I was walking around the room. I saw some really nice separation problems. I even saw some combining problems to help us solve this. So I'm eager to talk to you about it, and we can get all of our big mathematician brains talking and thinking. So in this first way, this red way here, I see their original number sentence, 254, take away 135 equals n equals 119. Ooh, that's a lot. So can someone tell me where do you think they got these numbers from, 254 and 135? Nick, where do you think that came from? The words. Would you read those words for me, loud and proud?
A total of 254 people entered a bicycle race. So far, 135 people have finished the race. Write a sentence and draw a diagram to find out how many people are still racing.
Great. So we have this bike race, right? And all the people in the race total are 254 people. Some people have finished the race already, 135 of them to be exact, and we want to know how many people are still left in the race. So left in the race, I believe this person said n is the number of people that are left in the race. So they took their first number, 254, and they took away 100. Why did they only take away 100? Kaylee?
Because they're like when you do that kind of math, you have to you have to take the numbers and then subtract the hundreds.
Okay, so you're telling me that it was just the hundreds place. There were 100, so they subtracted 100. Okay, so we've gotten that part. Then they got the answer 154. Then they took that answer, 154, and took away 30. Where did 30 come from? I didn't see any 30s in the problem. So where did that 30 come from, Graham? The tens place in the number 135. Great. So they took 154 and took away 30 and got 124. Then they took that answer, 124, and took away 5. Where did that 5 come from? Gracie?
The ones place.
The ones place in the number 135. So this would be like our hundreds, tens, and ones. And they came up with the final answer, 119. 119 what? What's our label in this problem? Gavin R? Yeah, racers. Or people that need to finish the race. Racers that are left, yeah. So we have 119. I'm pretty sure that's our answer. What is this strategy called? What's this strategy called, Emma?
Break down place value.
Yeah, breaking down place value. Okay, so then I see some other work here. By the way, did they follow the directions? Did they write a number sentence? Yes. I see that right here. 254 minus 135 equals n. Here's our number sentence. Did they draw a diagram? Let's take a vote. Thumbs up if you think they drew a diagram. Thumbs down if you think they didn't. I see a lot of thumbs down, but I do see some thumbs up. Gavin R., can you tell me why you think they did draw a diagram? They did do it in a way. You're right. Brittany, I saw your thumb down. Why do you think they didn't draw a diagram? What are you thinking, Brittany? Why'd you put your thumb down? Did you forget? Okay, maybe somebody could help her out. Gavin H., I saw your thumb was down. Why did you think this is not a diagram?
Because there's no picture. Because there's no picture.
Yeah, there isn't technically a picture. This is a wonderful strategy. It did help this person find the answer, and that's great. I highly recommend this strategy for that person. They can understand it. They can explain it. Great. But it doesn't technically count as a diagram, just as a strategy. So let's look at the green way here. I see they've got a number sentence. It looks like maybe they looks like the standard way here. I see a part-whole picture here. I see some more numbers in standard form over here. So what do you think this person was doing? What strategy would we call this? Just the same like 4 or 5 people. I want to hear from everybody. Turn and tell your partner what strategy this is. Thank you. Great. Will you have a seat, please? Come back to me in 2, 1, 0. Thank you, Emma. What is this strategy called?
They were using a part-whole picture and the standard way to help them.
All right, let's see if we can make sense of this strategy, this part-whole picture. So I know this part was at least already on your paper. There were 2 parts. And it said 135 is the first part because those are the people that have finished the race already. The whole number of people is 254. So how do you think they came up with this missing number? Look at their work and see if you can figure out what they did. Does anyone have a suggestion? Maybe we could work to figure out what this mathematician was thinking. Kendall, what do you think?
They were adding 135 to 19 so they see if they get 254. And
Oh,
they did.
Whoa, whoa, whoa. Are you telling me they did addition for this problem? We have been talking all day about separating and using subtraction. And in this person, they had 4 separate number sentences, and all 4 of them were subtraction. And then this mathematician, so they're probably wrong, right? Because they did addition, and that's not what this person did. Why do I see so many heads? Isabel, can you tell me what you're thinking? Why isn't this person wrong? They did addition. Oh. Tell me what's the deal?
Because there's so many ways to do a problem. You don't have to do it in subtraction. It's almost the same thing, but you're doing it in a different way.
Oh, okay.
To help support the subtraction.
Interesting. So tell me what that's called. Does anyone know when you have like related facts? Some are addition, some are subtraction. Does anyone remember what those are called? I would love to call on you, but you're not with our group. Kimmy, do you remember? Oh, fact families. Okay, so let's see if that really makes sense. In this problem, I see 254 minus 135 equals 119. In this one, I see 135 plus 119 equals 254. Thumbs up if you agree. These are in the same fact family. Yeah, I agree too. So I know this person is probably right because even though they did addition, they can still solve the same problem. So they added those 2 numbers to get their whole, and because the whole was the same as their picture, they knew that missing part was 119. So I like their number sentence here. So let's see if we agree. Did they follow the directions? Did they write a number sentence? Yes. Did they draw a picture? Yes. So they followed both of those rules. Last one we're going to talk about, excuse me, Kimmy, I don't want to step on your fingers. The orange way here. I don't see any addition or any subtraction, so that tells me this person is definitely wrong because they didn't even do any math. What kind of mathematician doesn't even do math? Oh. So they're probably wrong. Why are they not wrong, Nick?
Because you're using a different form, and it's a picture.
Ah, it is a picture. So are you telling me we can solve without even writing any numbers? That blows my mind. So let's take a look at, see if we can figure out what all these squares and lines and dots possibly mean. What do you think these big squares mean? Graham, what do you think these big squares mean? Hundreds. Interesting. We call those hundreds flats. What about these lines? What could those lines mean? Maddie?
Base 10 blocks.
Oh, so the whole thing is base 10 blocks? What are these lines called? Or what do they represent? Tens, rods. And what about all these little circles down here? Gracie?
Ones.
Ones. Okay. So it looks like they drew 2 hundreds. 1, 2, 3, 4, 5 tens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 ones. Where did they get that number from? 2 tens, 5 hundreds, 14 ones. I don't see any number that looks like that. Emma, what are you thinking?
They got it from the biggest number or the least number.
Okay, so the biggest number, well, that was 254. So how did they get 214? That's interesting. Let's see if we can figure out what this person did. So if we are taking away the number 135, I bet they were trying to take away 5, but they only started with 4 ones, because in their original number, 254, they couldn't take those 5 away. So what do you think they did? Nick, what do you think they did? They might have regrouped and taken one of these tens and broken it up. So if they started with 4 and then they added on 10 more, that might be why there are 14 ones here. So then they could take away the 5 and they had 9 left. Then they could take away those other 3 tens and they had 1 left. And then they had 100 left after they took that 100 away. So they got the same thing. 119 racers. I'm going to add our label. Racers. Oh, they already had a label. So did this person follow the directions? Did they write an equation or write a number sentence? No. Did they draw a picture?
Yes.
Yes. So a number sentence, if we wrote a number sentence for this problem, will you tell someone near you what that number sentence would be?
It would be 250.
Marissa, will you talk to Emma and tell her what the number sentence would be? Alana, will you talk to Sadie and tell her the number sentence?
135.
Lauren, will you talk to Kinley and tell her the number sentence? Raise your hand when you know the number sentence. Blake P., tell me the number sentence. Oh, that cap is going to drive me crazy.
It would be 120.
Oh, I don't see any 120s for our number sentence. We have the numbers 254, we have the number 135, and we have the number 119. Those are the 3 digits that we're working with, or 3 numbers.
135 plus 119.
Okay, so that's what I see here, 135 plus 119, but I don't think this person used combinations or combining to solve their work. So can someone else help me? What is the number sentence that goes with this problem where they're separating? Gracie?
254 minus 135 equals n.
119 or n. Great. The last way I'm going to solve real quickly, I did see a lot of people using the standard way, which I told you is not my favorite way, but I did see that was one of our most popular strategies in the room. So I would like for you to check my standard way work, and I would like for you to check it with your standard way work and make sure that what you are doing is the same. So we start with our biggest number, 254. We're taking away 135. 4 ones minus 5 ones gives us negative 1 ones, and we don't want any negatives in our answer. So we're going to take our tens place. We have 5 tens, so we're going to take one of them away and bust it up into ones. So we have 4 tens and now 14 ones. 14 ones, take away 5 ones gives us 9 ones. 4 tens, take away 3 tens gives us 1 10. 200s, take away 100, gives us 119 racers. When I say go, we're going to solve our exit ticket, and I think we have some time for X's and O's. So when I say go, we've got to be quick and quiet. Back to your seat. Brittany's going to give you a note card. Go.
specials today?
Yes, I can. Thank you. I love how Emma came back to her seat. Thank you, Emma. Nice job, Chase. Thank you, Sadie. So here is our problem. This is our exit ticket. Since we've got an election coming up, this is the U.S. representatives, which are people that we elect into office, kind of like a president. In California, the number of representatives is 53. That's 53 people that hold this job. Florida has 25 people that do that job. Michigan has 15 people that do that job. And Texas has 32 people. So here's the problem I want you to solve. Draw a diagram and write a sentence to show how many more representatives Texas has than Florida. So can someone tell me how many representatives Texas has? How many are in Texas, Kaylee? 32. Oh. 32 in Texas. What about the number of representatives in Florida? Emma?
25 people.
25 in Florida. Does this question ask us about California or Michigan's number? No. So in our data table, that's not necessarily information that we're going to need. So on your card, write a number sentence and draw a picture to solve this problem.
Go.
Draw a picture and write a number sentence. Yes, girls. That's fine.
Can we do it in standard too?
If you would like to check it using the standard way, that's fine, but I do want to see a number sentence and some type of picture.